Hello friends, this is the first electrical video where I will be showing how to install a single gang box and run its home run wire for this outlet that we'll be installing in the future. I work in the construction field, but unfortunately I injured my knee a couple of weeks ago and haven't been able to work because of my current condition. But that doesn't stop me from making a video that hopefully helps out those wanting to learn in the electrical field. Even though I'm also learning myself, but I know I've learned some stuff that I like to teach as well. So to get started, let's start with this single gang box here. This single gang box, as well as all the electrical equipment or materials that you buy, needs to be UL listed, which means that it's been tested by the Underwriters Laboratory to meet normal and abnormal conditions when being used. So for example, this single gang box, if you look at it, unfortunately now you can't see it from this camera, but there's a UL listed marking which has a UL on the bottom left corner here, which indicates it's been tested and it's allowed per the NAC code, their National Electrical Code. The National Electrical Code is stipulated so that way it states, or it emphasizes, the minimum safety requirements for the safeguarding of people and property. That's why we use the National Electrical Code, for the safeguarding of people and property. And it's, as I mentioned, the minimum requirement of what to do when doing some certain installations of electrical. All right, so let's get started with this. I'm going to be mounting my box. Typically we mount these boxes at 18 inches from the floor that's unfinished. This floor here has about half an inch of flooring, hardwood flooring already. Because of that, I'm going to account for that. So for 18, that would mean that I would take a half inch off, which I will be marking here. So I'm going to go 17 and a half, and that gives me my 18 inches from the bare floor if there was no flooring. But I know we have half-inch flooring, we're going to go half inch. I'm going to mark half inch less, so I'm going to mark a 17 and a half. I'm going to put this line here and this line here, indicating that I want my receptacle to be on this face of the 2x4. Then I'm going to also mark an outlet symbol here. This indicates that if I'm not the one running this or installing this boxes, whoever installs the box knows that this box is going to be a centered line to this line, because that's how we do our jobs here, and it'll be for a receptacle, which is that symbol. So all you have to do now is grab your 1 gang adjustable box and mount it to where it's center line here. So once you mount it there, then it could hold on by itself. We then want to screw this down. That way we have it in place and ready to go for when we start running our wires here. We will go ahead and screw it down. This has 4 this bracket has 4 entry points for screws, so 2 in the front and 2 on the side here in the back. Bear with me here because I can't really bend because of my knee, so I'm not going to put in this last screw at the bottom, but that should hopefully be enough. That should be enough to hold that box in place. Now that we have our box, we want to go ahead and map out where we want to drill our hole to run our wire. Because you can see, let me get up here, we have our panel on this bay between these 2x4s, and our single gang box is in the next bay over. So we want to obviously come over to this side. In order to do that, we got to drill a hole on the 2x4 stud. This is a short run, but the idea is the same if you have multiple bays of 2x4s you got to get to include more outlets for the same circuit. You just want to get a height to where you'll be making your holes so they look nice and even, or on the same plane. In this case, I want to go with I want to give it some room here, so I'm gonna just go 28 inches. So at 28 inches, I'm gonna drill my first hole so I can pass my wire. But here's a perfect example. 28, we're really close to this screw here that's on the 2x4. So now that I know that, we want to make sure we avoid anything that can mess up my wire or my bit that I'm going to make this hole. So because it's kind of close to that, I'm going to probably go a little higher now that I see that. So always keep in mind, when you're before you drill, always, I'm going to go at 30 inches now. Before you drill, always look at where you're going to be drilling, around it, behind it, everywhere, to make sure that you don't hit anything, a nail or an existing wire, because you don't want to damage anything. You'll open a can of worms if that happens. All right, so now that we have our marking here, per the NEC code, the hole that we drill on this 2x4 has to be no less than 1.25 inches from this face where our sheetrock is going to be installed in the future. That's because we don't want our wire to be installed through a hole closer to this edge, because then that has a possibility of getting damaged by a screw from the sheetrock or just anybody else doing something to this wall in the future and driving screws and hitting your wire. So at a minimum, you got to put 1.25 inches distance from this face. So you can go ahead and measure your 1.25 inches here. But in this case, because I know we're not going to put sheetrock on this face because this is a furred wall, there's no sheetrock going to be placed on this other side of the 2x4. I'm going to make it further than 1.25 inches, and that's just to protect the wire even more. So I'm going to even put it, I mean, if you want to measure it, I would say 2 inches. So you go here, you have your 30, you go place your 2-inch. So where this dot is, I would be making my first hole. As I mentioned, that's to prevent damage to the wire in the future from the sheetrockers or from anybody that's doing future work. Once the sheetrock's installed, you can't see your wire back there, so you won't know what you'll be hitting. All right, typically we like to use 7/8 bits to make our holes, so we can run maximum. I like to run 2 12-gauge wires on 7/8, or we also use 5/8 bits to make our holes. In 5/8 you can also run your 14 2-wire, which is a smaller gauge. But in this case, because I like to have enough room for the wire to just slide in with least minimal resistance, and also more space, I'll just run I'll make a 7/8 hole. So here we go. Put it on our dot. Always, obviously, make sure you drill on this right settings. I like having it at high speed, and just drill through. All right, we've made now our hole, and like I said, it's obviously more than 1.25 inches from this face of this stud that's gonna have sheetrock. And also you can add a nail plate just for extra protection. If your hole is less than 1.25 inches, the code stipulates that you need a nail plate that's at least 1/4 inch thick, if I'm not wrong. But yes, you would need a nail plate. I like putting nail plates regardless if my distance is further back, just for safety. So in this case I don't have one with me, but I will put one in the future, a nail plate here. All right, as we move along here, now that we have our hole, we have our box mounted at our desired height, and now we're here at the sub panel. I've already knocked out a 1/2 inch hole so I can drive my wire through here. It's going to be a Romex wire. But before I do that, I need to install my Romex connector. This is just a 3/8 Romex connector, and I like using these because they're nice and sturdy, and they also protect the wire from the sharp edges from the knockout on the panel. Just install that with its lock nut, and then I like using this tool here to tighten, and I like this connector to be facing me so I can tighten it down once. So all you do is tighten this down. This tool makes it easy to install. All right, now that we have that, another thing that's very important when working with electrical, we all know that electricity it's dangerous. So always assume everything is hot and has power, even if it doesn't. But in this case, this panel has power. So I'm mindful of that this is hot and that I can get injured if I were to touch this and touch ground. I will complete the circuit and get shocked. So just to verify, you will make sure that you do hear that it's hot and you know that it's hot. So now that we know it's hot, we just continue on with safety in mind for our health, and you don't want to get injured. So yes, so that's hot. Now that we have our connector in, like I said, I'm going to run a 12-2 Romex. Like I said, this is a simple circuit, but the idea is here to do it right. Do it right, so that way you can apply this to many other electrical runs that you'll be doing. So for example, I like to run my Romex wire all the way to the top of the panel and leave that much wire inside. That way I know that I have plenty of wire in case I need to do anything with it. I have plenty of wire to land it on a breaker. So here now I'm tightening down this. I don't like to tighten down this Romex connector screws here that much because I don't like to put any pressure on my wire. I just like to have it snugged, because all its purpose for this Romex connector is not to hold it in place, but to protect it, like I said, from entering this knockout from its sharp edges. Now that I have that in, I want to drive down. I like using staples. These are the staples I like to use when it's just one wire. If it's multiple wires, I do like to use stackets. I don't have a stacket with me right now, but in the future I can have a stacket with me and show you how that looks. So I'm going to drive this staple in. This is a 9/16 staple. I'm going to drive it in. So when you drive these in, as I mentioned, I don't like tightening it too much at the Romex connector, so it's a little loose. So the code, the NAC code, states that if this wire goes into a box that it's not secured, the wire at its entrance, in this case this Romex connector, I don't have it as tight, and so then I like to apply the rule that I will drive your first Romex staple or your staple within 8 inches of the panel entrance, because you can have it 12 inches if it was very secured at the panel, but because I like to have it loose, I'm gonna go with it. You can have your own rule of how to count. You don't have to measure 8 inches, but At first you might have to, just to get an idea where 8 inches are, or you can just have a habit of maybe having your hand here and saying, okay, that's about 8 inches. So then you grab your wire and you start driving down your staple. Personally, I don't like to drive my staple in that far because, like I said, I don't like putting pressure on my wire. The code then states that obviously for long runs you want to staple your wire every 4.5 feet, meaning 4 feet 6 inches. You have to staple your wire if it has a long run. But in this case, this is short. You can just staple it closer than 4 feet and 6 inches. So right now I'm just feeding my wire through. Okay, there it is. So I like having nice big loops so I don't kink my wire. I don't put pressure on my wire. I want my wire to look smooth and well run, because you don't want to have any kind of pressure, any kind of kinks in your wire. It just doesn't look right, and it's not good. So now that I have my wire around the way I want it, I take my second staple and I start driving it. And as mentioned before, drive it in just enough. And also be mindful that this 2x4s have wood nuts. These wood nuts are hard, super hard to drive anything through them. So you want to avoid them if you see them. And in this case, I saw it, so I'm going to drive it a little bit lower than that knot. This knot here. All right. There it is. All right, as you can see, I also like running my Romex further back on the 2x4 to protect it from any potential screws that are going to go through the sheetrock and miss. You don't want them to hit your wire, so that's further back as well on the 2x4. All right, so let's continue on here. Let's finish this up here with, I like using needle nose pliers to open this back port to insert my wire. Just go like that, open that up, and feed your wire through. It's just harder when you're injured, trying to do any kind of work when your knee is not 100%, but we'll try to get it done. All right, there's your wire, and I like my wire to look nice and straight when it enters the box. In this case, we have a wire here, and I like to put another staple here myself as well. And I like to put a little bit, you see this half a distance between this hole and the box. All right, now that we have our wire through our box, we wanna, the NSC code states that you require a minimum of 6 inches coming out of the box total. So that means that from the back of the box to the front of the box is 3 inches, let's just say and a half. The total amount that it has to come from the back of the box to the front is 6 inches, which would be here. So another 3 inches. So you can grab your wire and measure it if you want. But I always like to leave my wires a little longer, and then I can always trim it down when I start doing the makeup for this. So I'm going to cut it at 9 inches. It's just a habit that I have, cutting it longer. Now that you have your wire, and because I will not be doing the receptacle at this moment, you want to just make sure your wire is folded inside your box. That way it doesn't get damaged from any other trays that are going to come by and install the sheetrock or do whatever they're going to do. You don't want them to damage your wire, especially once you have it installed and everything's covered up. And if it gets damaged or gets shorter than what it is because it was damaged halfway through, then you're pretty much going to end up working with that wire that's there, because there's no way you can get it out anymore once everything's closed up. So that's it for this video. It was a quick video, somewhat quick I guess, but that's the idea, to do things the way that protects your wire, and it protects what keeps mindful of electrical safety. Hopefully in the next video I'll also want to install a receptacle and install the breaker, but as well I want to stop by at a job site that I was part of before I got injured and show you guys what's the progress in that one project and just share some insight. All right, well, thanks for watching. You guys have a good one.